I will demonstrate a basic Level 1 hardware application for Oleumtech hardware, which includes a Modbus master. We will use a software to emulate, a Modbus slave. We will use the DH2, connected with a black phantom antenna. We will have an end node reporting of a discrete transmitter, which is connected to a high tank level switch, which has a float, which engages the switch. We will use our configuration cable for DH2, our pigtail for transmitter configuration, and USB to serial converter if needed. Now we will move on to the software configuration. First, to configure any Oleumtech hardware, you must have Breeze configuration software. If you do not have it, please go to www.oleumtech.com, use these instructions to download the software. Once you have the software, you open it. First, go to Edit, Options. Here you will set up your PC port parameters. Identify the port you are using. Leave at baud rate 57600, none and 1, for these are the parameters of Breeze. Then OK. Then select a new file. Today we will name it Discrete Switch. The 2.4 GHz checkbox is for overseas hardware only. The channel availability is up to 9. The group availability is up to 999. We ask that you set this as you wish, but dial away from each other if in fact sites are closer than 2,500 feet. The bit rate defaults to 9600, but can be set at 115,200 if needed. The enhanced site security should remain checked, and this will preserve your data and not allow sites to crosstalk. And then click OK. Now double-click on the name, right-click, and go to Insert, your first piece of hardware, a DH2. Then double-click on DH2, right-click, and rename. Today I will name it DH2/RTU. Signify that I am interfacing to an RTU as my Modbus master. Then right-click, go to Properties, Edit. We will set up all parameters for the DH2, starting with Radio tab. Here, at the Transmit Power, you have a power supply available, so you are allowed to set up to 1000 milliwatts, which is a watt. For testing purposes, 1 or 10 is sufficient. Leave retries at 16. Move to Configuration tab. Leave settings at default 57600, none, and 1, for these are the communication parameters of Breeze. The Communication tab is signifying the RJ jack in the back of the DH2. Then go to the RTU tab. This is signifying the 6-pin Phoenix connector in the front of the DH2 that you can wire for 232 or 485. If wiring 485, check this box. We are a slave to the master. ID the slave, other than 1 if needed. If you need extended register addressing, you would check this box. If you needed to split 32-bit values in your RTU, you would check this box. The baud rate should be set for what your RTU or PLC is. Today we will use 9600, none, and 1. Then click OK. Now that all settings are complete for the DH2, double-click on DH2, right-click, and insert your next piece of hardware, which is a discrete transmitter. Double-click on transmitter, right-click, and rename. Today, I will name it Tank 1 High. Double-click on Tank 1, right-click, go to Properties, Edit. We will now set all parameters for this transmitter, starting with Radio tab. Because this is a Class 1 Div 1 with a standalone battery, 1 or 10 milliwatts is all that is allowed. We recommend you go to 10 milliwatts if your distance is greater than 100 feet. The node timeout is an RF flag in a Modbus register that signifies to the DH2 if data has not been received within this time setting. Leave this at default of 15 minutes. For the discrete transmitter is a cry-out device, but does send a health packet every 5 minutes. Leave retries at 16. Move to discrete inputs. Here we will name the discrete input. Today we will name it tank high. We can set the mode for normally open or normally closed, whatever you prefer. The debounce can be set at whatever you think is necessary. We suggest we set it at ample to know that your switch has been contacted fully. Notice that there are two different points you can set up two different discrete inputs. Our device comes hardwired for two different switch capability, and you can hardwire any type of dry contact switch into said transmitter. Now move on to Exports tab. Here we can set up what all registers we want to be exported from this transmitter to the DH2. Simply by clicking on one and transferring from one side to the other, everything on the right is what is available, and everything on the left is what we actually want. Today we want DIN1. We want DIN1 count, so that way we won't miss any of the switches. We want the battery voltage of the transmitter, and we want the RF timeout as well. So there you see we have 4 Modbus regs that we are asking for from said device. Then click OK. Now that configuration settings are complete with our second piece of hardware, we are ready to build our Modbus list. Double-click on DH2, go to Imports in your center window, and you will see the 4 that we are importing from the transmitter. Click on the first, go to the bottom, shift-click, right-click, and go to Modbus and paste to float table. Then go to Modbus tab and confirm that all 4 did in fact paste. 7001 through 7004. You see tank high, the tank high count, battery voltage, and RF timeout. This is your Modbus list. This is what you will build your request block from your Modbus master to ask for. Now the Breeze configuration file is complete and ready to be updated to hardware, so hardware will take its respectable position. But first we must save the file. Click the Save button or File Save. Name the first half of your file. Today we will name it Level 1 Tank. So now we have a Level 1 Tank. Discrete Switch is our named file, and we are ready to update hardware. The connections for the DH2 are a Phoenix connector in the front for 232 or 485 communication wiring to interface to your Modbus master. You also have jumpers beside this connector that must be installed if using RS-485. You also have a power and ground connection. On the back of the DH2, you have your configuration port, an RJ jack, which is used to download your configuration from Breeze. On this side of the DH2, you have an MMCX connector, which is used to connect your antenna. And that is all the connections of the DH2. To download the configuration file to the hardware, you must first connect your configuration cable from the PC to the DH2 at the configuration port. Then double-click DH2, right-click, and click Update Device. In your Build tab of your Output window, you should see DH2 Configuration Download OK. If you do not, then the file was not accepted and updated in the hardware. try to update again.
Transmitter connections include a 3-pin flat for battery connection, a 4-pin flat for breeze configuration connection, and the reset switch is located right beside both connections.
Now that the DH2 has been updated correctly, we will move the configuration cable to the discrete transmitter using the pigtail with 4-pin flat connector. Once connected, double-click on tank 1, right-click, and hit Update Device. If Site Security Mismatch window appears and asks, do you want to reprogram the security key on the field device? Yes, we'll change the key. No, we'll not change the key, but both will push the file. We want to use yes because we have a new file today. Confirm the configuration download OK in the Build tab. Once done, you know hardware is updated. While still connected to discrete transmitter, double-click, right-click, and click Connect. Once connected, we will do a local read. Click on Discrete Inputs, click the Read button. This will show the value of our discrete input 1, because we only have one wired to this particular transmitter. The blue bar will show RF OK, or no RF. The RF OK means that the DH2 acknowledged the data correctly. OK, that's green. Move to your bottom window, click in the Debug tab, then click the Read button again while viewing your debug window. You see the data string go out to the DH2, and you see that we have a discrete input of 0. Now I will go and move the switch and reread. Now that I have moved the switch, I will read again. Notice how I have a discrete input of 1 and a count of 1. We have now confirmed the local read capability and have confirmed in debug that the data is being sent to the DH2 and being acknowledged. We can now move over to the DH2 with the configuration cable and monitor the debug from there. Now I have moved my configuration cable back to the DH2 and have my debug tab open in my output window. Notice the RX packets coming from group 2, node 1, with a received signal strength of 41, 40, 40. You notice a packet comes out every time there is a state change of said switch. I have switched the switch 3 times. Now we know the switch is working. We know that data is being sent and confirmed in debug at the DH2. We are now ready to set up the Modbus master. Today, I will be using simply Modbus as our Modbus master emulator, using COM1, 9600, 8, 1, and none. My slave ID is 1. The first register I'm asking for is 7001. I'm going to ask for 4 registers. Over here is where my results will come in. And if you notice that I am set up to ask for the same thing that the Modbus listing in Breeze is set up. When I click Send, the value immediately goes out, and in debug you see the response to the request, 7001 through 4 with their value. A 0, the switch is in 0 position. There's been 4 switches made. The battery voltage is 3.6, and there is no RF timeout. And you confirm that within your results of your Modbus master as well. Now I have switched the switch again. You notice the RX packet comes in to the debug of the DH2. Now I will send the request again. Notice the response go out to the Modbus master, and 7001 has changed to a 1, and count has went up to 5. And on your master side, you can confirm that as well. We have now completed the basic level 1 tank discrete switch configuration Breeze file build. We confirmed data all the way through debug and Modbus master emulation. You can easily accomplish this with multiple end nodes